This is Francis Sadeko with another episode of TIRIASCast. I'm here with Jillian from GuardKnox. So Jillian, maybe you could just do a quick introduction of yourself and the company.
Awesome. Yes, hi, I'm Jillian. I am the CRO of GuardKnox. We are an auto tech company. We build secure software and firmware solutions for the next generation of the software-defined vehicle. And focusing on the automotive industry, specifically on the core EE solutions, which actually enabled the software-defined vehicle. So we actually have two main products. One is our SOA framework and developer tool suite, which is a secure software middleware framework for comprehensive lifecycle management, as well as obviously our tool suite, which does development, deployment, and analysis. So we have a model-driven modeling tool, as well as an analysis tool for actual quicker deployment of applications and also enabling a much quicker time to market through our automatic code generation. And our second product is our COM engine, which is a single chip secured ultra fast routing and switching solution for the automotive industry, really enabling the next gen zonal architecture. It actually is almost like a zonal gateway on a chip. It is secure by design, obviously, works with multi-communication interfaces, and has a guaranteed bandwidth as well, which actually overcomes a lot of the challenges of purely software routing and switching solutions.
So speaking of those challenges and given those products, what are some of the kind of maybe larger problems that you guys are trying to help solve with the industry?
That's a great question. So when you look at the industry, and the transition to the software-defined vehicle, where a vehicle's functions are determined more by the software than just the hardware components. We are transitioning to the zonal architecture where we need to actually consolidate the number of hardware components, the number of ECUs in a vehicle, as well as consolidating all the wiring as well. And when you actually do that, you actually are introducing latency. Because you now have to go through multiple hops. You also have a lot of issues with communication protocols. So I'm going from CAN to LIN to Ethernet, GPIO, MIPI A-PHY, and we need something that A, speaks the same language, can do it in a super fast way, can handle high data loads, is obviously secure, and that has that guaranteed bandwidth and throughput. So that is exactly at the heart of our COM engine solution. And as the industry continues to move towards zonal architectures and actually enabling that functionality, because as we want to also enable autonomous driving functionality, we have the safety component that comes into that. And safety is a huge issue when you look at latency. So we're talking about milliseconds, microseconds. So we're working on less than more than 3 orders of magnitude different than what the industry is saying it needs, because it doesn't matter the amount of time that we're looking at here, as well as our bandwidth that we're looking at for all of this. So that's a huge issue that we're addressing, as well as the software aspect. So we from a marketing perspective, we like to call it the smartphoneization of the automotive industry, but that ability to deploy and model and deploy applications in the entire vehicle. But the issue you have there is we have so many different domains. So you see a lot of solutions that maybe typically what you see is like, for lack of a better word, sexier solutions, which focus mainly on ADAS or infotainment, which is great, but you need something that is purely domain agnostic, that works across all the domains, that actually can connect my cloud, my zonal gateway, my HPC, my edge, my subzonal gateway, all in one unified area, working agnostic to all the different OS vendors, all the different hypervisor vendors, all the different underlying hardware, SOCs, FPGAs, ASICs, whatever you have. You need something that really unites everything in a consistent and secure framework, which does that containerization, that partitioning to enable that mixed criticality. So you can actually deploy applications to give you that added functionality and deploy it across the entire vehicle to enable that signal to service-based communication.
So obviously the industry is talking a lot about going zonal architecture. What do you think is driving the industry to that architecture as opposed to how we're doing it now?
So I think one of the biggest use cases you can look at is what's happened to us with the global chip shortage.
Mm-hmm.
I mean, where you had, I was just in Detroit, and there's thousands of vehicles sitting
there, yeah.
because they're missing such a small component.
Right.
And we know that this isn't scalable. We also know there's like the length and the labor, just the labor required with all that wiring harness. But when I want to deploy an application, I have to work with all these different suppliers with all these different protocols and who talks to who, and it just becomes, I like to call it an ECU soup.
Right.
And the industry is saying, hey, we know this is an issue. A lot of our newer entrants who are not burdened by the legacy are able to actually build that zonal ring topology. Typically is what we're seeing more of, but there's also the star and a number of different topologies. They're actually able to deploy that quicker, enabling a totally different driving experience. And so I think that's where the industry has said, hey, we know we want to go there. And I think that's really important for us as GuardKnox to say is, we're not here to change the entire industry and say, you don't know what you're doing, because that is like the dumbest way to work with someone, right?
Right.
We're saying, we know where you want to go. We understand your issues, your challenges right now. And we're here to enable you to, with our tagline, to give you the freedom to evolve.
Cool. So what are you guys specifically showing here at CES?
So at CES, we have an AR demo, which is a nice visualization, and we'll send you the video and everything for that as well, of our entire product line. So we take the car and we kind of undress it. We look at the software, we look at the hardware, and we really understand what we're seeing there. And it's a nice introduction to our solutions. And then we have a chassis demo. So in our chassis demo, we've actually built a full zonal architecture. So you'll see a zonal gateway, a subzonal gateway, and an HPC. And we've identified 3 different use cases which show multi-protocol routing, and you'll see the GPIO to the Ethernet, as well as CAN and LIN, which we are using through wheel sensor use case. We also will show ultra low latency routing, which we are showing through a camera use case, and actually also showing that higher data load. And then we have our SOA framework and developer tool suite scenarios where you're actually going to walk through and build a new application, and then you're actually deploying it over the air to the vehicle and understanding how you are able to get new functionality. In this case, we're actually building an application for high beam assist and deployed to that vehicle. And then we have a way more in-depth developer tool suite where you really can look at our tools from scratch and actually as a developer build them.
So the developers that you guys are targeting with that suite, is it the tier 1 guys or is it the OEMs? Who are you seeing or trying? One of the things I think that we've seen is the OEMs are trying to get a little bit more control over their own destiny, right? I mean, instead of being so dependent on the tier 1s or the app developers that are third party to them, who are you guys seeing really getting interested in the developer suite and and maybe building up some value added capability?
Yeah, I would say for GuardKnox, our main customer is going to be the tier 1.
Okay, great.
We do have OEMs here because it's a lot of fan building and them wanting to understand. But
you almost have to drive the demand from the OEMs for your stuff so that tier 1s can then work with you guys.
It's that push-pull type of strategy for sure, and the fan building. So those are our main. We also have a number of partners here. We partner with a number of different OS vendors, DDS vendors, kind of everything in between. It's
kind of funny you mentioned the smartphoneization of the car because that's exactly what happened with the chipset manufacturers for the smartphones. Companies like Qualcomm, they had to market to the operators so that the operators would then pull their actual customers, which is the smartphone manufacturers, to grab their stuff. So it's kind of interesting that same parallel is happening here. One kind of other question, you mentioned a lot about like the different communications buses and things like that. Do you think, with the sheer amount of data coming from all the different kinds of sensors, whether it's LiDAR, radar, the camera being used as a sensor and so forth, plus everything else that you're trying to do on top of it, is it going to start coming down to potentially just all Ethernet? Are we going to see basically a data center in the car, or do you think we're still going to have to deal with all the different kinds of communications infrastructure within the car?
I think based off what we're seeing is you'll definitely have a high-speed Ethernet ring. If you have like a ring topology, CAN is not going away, right? It's been here forever, but CAN is not going away. LIN isn't going away. GPIO is not going to go away. Obviously, A5 MIPI is not going to go away with our cameras. I think what you're going to see with the zonal architecture enables is we can use all these different protocols and get them converted to Ethernet, and then the critical part of the communication path will be Ethernet. For sure.
So last question before we kind of go on to the demos. Do you do your own kind of ECUs and chipset architectures, or do you work with some of the more typical semiconductor manufacturers and then you put your solutions on top of that?
So we do work with, we have an FPGA based one, so we work with both AMD and Lattice. We also work with a number of different ASIC companies, traditional ASIC companies, NXP, TI, those type of companies. And we also can do, a very customized solution. So it definitely depends what we're looking for. FPGA obviously has a lot of benefits, and it also has a lot of drawbacks. And the same thing kind of goes with ASIC. I think when you're looking at FPGA, it's a quicker time to market. It's easier to deploy into the field, but long term, definitely looking towards ASIC as well is what we're kind of focused on.
Perfect. Great. Well, looking forward to the demos. So everybody stay tuned for part 2.